In this lesson, we will look at quadratic sequences. And before we start, just the usual to remind you on how to do mathematics. Now, make sure that you understand all the steps in the examples. Then secondly, you do not learn how to do maths by reading it or watching someone else explain it to you. Understanding steps does not mean that you can do it on your own. So therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. So you improve your skills only through practice, but more specifically marking your practice sums and learning from your mistakes. Now, overview of this video, what we'll be doing, first of all, we're going to look at calculating the next two terms, then how to find the general term, then using the general term to find the Tn value when n is given, and then vice versa, also using the general term when n is given, and then solving for x and y. Now in example 8, it says calculate the next two terms. Now, as we saw previously, you can always look out for three things. In grade 11, you look out for either 90% of the time a common difference or a second common difference. And then in grade 12, you've got three important things to look out for. It's common difference, common ratio, and then what we're doing now, common second difference. Now, how we test it is you can actually just take out your calculator and then see, okay, if I say 8 minus 5, that's 3. But if I say 13 minus 8, that gives me, what does that give me? 5. So 3 and 5, so there's no common difference there. And then if you want to test common ratio, you'll say, okay, 13 divided by 8, it gives you, okay, 13 over 8. And then if we have, so that's like 1,6. And then if we say 8 divided by 5, it should give you the same thing. But it's not exactly the same, so it's not a common ratio as well. Okay, so then the next thing you test is second difference. So if I go and I say, okay, from there to there it's 3, then add 5, then add 7, then we'll look at the second difference. From 3 to 5 is 2, from 5 to 7 is 2. Okay, so we have a constant second difference. This means that this is a quadratic sequence. Okay, so what I'm going to do is I'm just going to carry on here, and then from 7 to get this number over here, we have to add 2, and that gives us 9. So from 20 to here, we have to add 9, so that gives us 29. Okay, and then again, this number over here, we have to add 2, which gives us 11. So 29 plus 11 is 40. Okay, so then our next our two next terms are 29 and 40. Okay, so for this one, calculate the next two terms. Now from 3 to 8 is 5. And from 8 to 17 is 9. Then from 17 to 30 is 13. Okay, so there we can see, okay, we don't have a common difference. Let's look at the second common difference. Second difference is 4, and then from there to there is 4. Okay, so our second difference is 4. Now, counting on, over here to get this number here, we have to add 4 again. So 13, that's 17. So 30 plus 17 is 47. And then we add another 4 to get this number. We add 4, and that gives us 21. And then add 21 to 47, that gives you 68. Okay, so that means our next two will be 47 and 68. Calculate the next two terms. So common difference from there to there is just 1. And then from 12 to 5, this one is weird. 12 to 5 is negative 7. Okay, let's see what happens anyway. Negative 7. And then from 5 to negative 10 is negative 15. Oh, okay, I see. This is actually working. So from 1 to negative 7, it's negative 8. And then from negative 7 to negative 15 is also negative 8. Okay, so the second common difference is negative 8. Going on, we have to subtract another 8 from negative 15. So negative 15 minus negative 8 will give us negative 23. And then subtract another negative 8 here. Okay, so basically if I go from here minus to get the next number, I can now subtract another 23. So that gives me negative 33. And then subtract minus 8 from negative 23. So that gives me negative 41. Negative 31, sorry. And then subtract negative 31. We get negative 64. Okay, so our two next numbers will then be negative 33 and negative 64. Okay, calculating the next two terms of these. To go from minus 7 to minus 9, you have to subtract 2. And then to go from negative 9 to negative 4, you have to actually add, because this number is bigger than this one. This one's more negative, so this one's more positive. So you have to add 5. And then from negative 4 to 8, you have to add 12. All right. And then from minus 2 to 5 is adding 7. And then from 5 to 12 is also adding 7. Okay. And then if we go and add another 7 to, so basically we need to know that number and that number over there. So we need to add 7 down here. And that gives us 19. And then to get the next number, I say 8 plus 19, and it gives me 27. And then add 7 again, you get 26. So adding 26 to 27 is 40 plus 13, so that gives me 53. Right, so we've got 27 and 53 as our next two terms. All right, so that was done. Then to find the general term. So this is the general term of a quadratic sequence. You have, it's basically a quadratic, it resembles quadratic functions. Then you've got to find the a value, the b value, and the c value. So there's always this n squared and plus the second term, which is always a number times n, and then a constant term for the third term. All right, so your Tn, as previously, is just going to be the term, the actual term number, and then your n is the how manyth term it is. So if n is, for example, 4, then your fourth term, Tn, is the fourth term's value. Okay, now in order to find a, we set up this equation. Now remember, this is what we do. If you get your terms here, if they basically just give you your first few sequences, then you get your first differences, and then we get our second differences as we did previously. So to find the value of a, you set up this equation which says 2a equals to your second difference. Okay, that's how you find a. 2a equals to the second difference. Then to find b, you will have 3a plus b is equal to your first difference. So meaning you've already now found a's value. So to find b, you set up this equation, 3a plus b is equal to the second difference, and solve for b. And then finally to find c, a plus b plus c is equal to your first term. Setting up that equation, that's now found. You solve for a, you substitute it into this equation, solve for b, substitute a and b into this equation, and solve for c. Then you basically substitute it back into this general term, and that would then give you your sequence's general term. Example 9 says we're given the sequence, determine the general term. Now over here we saw this was the same one as previously. We can see that from 5 to 8 we saw was 3, and then from 8 to 13 was 5, and then we have from 13 to 20 is 7. So the second difference was 2. Okay, so basically to find the general term, let's just write it down. The general term Tn is equal to an squared plus bn plus c. Okay, so my to find a, I'm going to say 2a is equal to my second difference. So then I solve for a, and a is equal to 1. All right, and then to find b, we have to say 3a plus b is equal to this number over here. So this was our second difference. 3a equals to b is equal to 3. Now a's value is 1, so I'm just going to substitute in 1 plus b equals to 3, and then solve for b. So taking this 3 over, b equals to 3 minus 3, so that's actually equal to 0. And then finally to find c, a plus b plus c is equal to my first term, which is 5. So I substitute in the known values for a and b, so that's 1 plus 0 plus c equals to 5. And then solving for c, c is equal to 5 minus 1, so c is equal to 4. All right, now that we have a, b, and c's values, we can just substitute them into this equation. So we have Tn is equal to, so a is 1, so I can just write basically n squared, because I don't have to write 1 n squared. Since b is 0, we don't have to include that term, because we don't write 0 in. It just falls away because 0 times anything is 0. And then plus c, c's value is 4, so that's going to be plus 4. Okay, and that's it. Okay, so we're given again this this quadratic sequence, and we have to find the general term. Now from 3 to 8 is 5, and then from 8 to 17 is 9, and then from 17 to 30 was 13, and second difference, this is 4 and this is 4. Okay, so to find the general term is Tn is equal to an squared plus bn plus c. So 2a is equal to my second difference, 4. So a is equal to 2. Then 3a plus b is equal to 5. So substitute in the value for 3. So 5 meaning that the first term in the first difference. So 3 substituting a's value that we already solved for, and then solve for b. So this is 6 plus b equals to 5. B is equal to 5 minus 6. B is equal to negative 1. And then finally a plus b plus c is equal to my first term, which is 3. Substitute in values for a and b, so that's 2 minus 1, say plus minus 1, plus c is equal to 3. So c is equal to 3 minus 2 plus 1. This minus 1 goes over and becomes a plus. All right, so then c is equal to 1 plus 1, so that's 2. Okay, so Tn is equal to, so a's value is 2, 2n squared, plus b's value, so that's minus 1n, or just negative n, and then plus c, so plus 2. Right, question 9.2. So once again, we need to find the general term, being Tn equals to an squared plus bn plus c. And just to remind again, when you're in a test or exam, they won't tell you, well, generally, most of the case, they won't tell you what type of sequence it is. So you're going to have to run through common difference, common ratio, and then look for common second difference. Okay, so at this point, we actually are aware that it is a quadratic sequence. That's why I immediately could write down the general formula for the quadratic sequence. Remember, there's a general formula for the common difference and there's a general formula for the common ratio, although the common ratio's general formula is only for grade 12s. So going back to the question, this was 1, this was -7, and this one was -15. And then my second difference is -8 and -8. Okay, so 2a. 2a is equal to my second difference, which is -8. So a is equal to -4. And then b's value, if I say 3a plus b is equal to my first term in the first difference, so that's 1. So substitute a's value, 3 times by -4 plus b equals to 1. This is -12 plus b equals to 1. So b is equal to 1 plus 12. B is equal to 13. And then finally, a plus b plus c is equal to the first term, which is 11. Substitute in a and b, -4 plus 13 plus c equals to 11. And then c is equal to 11 plus 4 minus 13. So c is equal to 11 and minus 13 is -2, plus 4 is +2. Okay, so Tn is equal to -4n squared plus 13n plus 2. Okay, question 9.3. Right, so first difference here is -2. Then this was 5, and then this one was 12, and then this is 7, and this one is 7. Okay, so Tn, second difference, common second difference, quadratic sequence, Tn equals an squared plus bn plus c. 2a plus, 2a is equal to my second difference, so that's 2a equals to 7, and then n is equal to 7/2. Right, and then for the b value, we've got 3a plus b is equal to this number over here, -2. Right, substitute in my a's value, so that's 7/2 plus b equals to -2. Okay, so I'm just going to take this term over. This is, well, let's simplify this first. 3 times 7, because remember this is 3/1. 3 times 7 is 21/2 plus b is equal to -2. So b is equal to -2 minus 21/2. All right, so let's just put that into the calculator just to be safe. -2 minus 21/2. So that's -25/2. All right, then finally we've got a plus b plus c is equal to the first term, -7, and substituting the values, so a's value is 7/2 plus b's value, so that's minus 25/2 plus c equals to -7. So c is equal to -7 minus, since this goes over, change the sign, minus 7/2 plus 25/2. And then if we add all of that, so minus 7 minus 7/2 plus 25/2. So that gives us 2. C equals to 2. And then just substituting in our general formula. A is 7/2n squared minus 25/2n plus 2. Okay, general term done. Now let's see at how to use it. Example 10 says the number of sequence, which we saw in the first example, has a general term of this, which we found, we worked this out. What is the value of the 30th term? Okay, so this is peanuts. This is really easy. So the 30th term, T30, my 30th term, I just substitute in 30 for n. So I just say, okay, my n value is then 30 squared plus 4, and then we just basically calculate that. Is 904. Okay, so the 30th term's value is 904. Question 10.1, the number sequence has a general term Tn equals to 2, n squared minus n plus 2. What's the value of the 52nd term in the sequence? So T52 is equal to 2 times by 52 squared minus 52 plus 2. Okay, and then we just type that in. So 5358. 5358. Number sequence has a general term. Tn equals to negative 4n squared plus 13 plus 2. What is the value of the 25th term in the sequence? T25 is equal to negative 4 times by 25 in place of n plus 13 times by 25 plus 2. Negative 2,173. Negative 2,173. Okay. And then the number sequence, blah, 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 has a general term of this. Find the value of the 100th term in the sequence. So T100, then substituting in 100 for n. So 7 over 2 times by 100 squared minus 25 over 2 times by 100 plus 2. So 33,752. 33,752. Okay, so that was quite easy. Now let's look at finding n. Right, so for example 11, it says that the number sequence 58320 has a general term Tn equals to n squared plus 4. Which term of the sequence is equal to 3848? All right, now in this case, it's quite important to know what it says, or just read thoroughly, because I've seen people actually just taking this number and substituting it in for n. So this is where reading plays a big role. Now, if they say which term is equal to this value, that means that's the term's actual value. So that means that's your Tn, right? Which means that you have to solve for n. Now, if we substitute in for Tn, we've got 3848 equal to n squared plus 4. All right, and then we just solve. So basically, if you have a variable with a squared, it's a quadratic equation. And with quadratic equations, to put them in standard form, we normally take everything to one side. All right, so I'm just going to swap this around, saying n squared plus 4 is equal to 3848, just to get my variable on the left-hand side. Then we take this guy over to the side. Now, there's actually two ways to solve for this. We can take the 4 over to this side and basically square root both sides. I think a lot of people actually prefer that, but since I'm in the habit of when I see quadratic equations, I bring everybody to the one side and factorize. So we'll have n squared plus 4 minus 3848 equals to 0. And then that's equal to minus 3844 equal to 0. Okay, so in this case, we can see that this could be, if this is a perfect square, this could be difference of squares. So if we can test it, and it most likely will be a perfect square, because when you're working with patterns and they say which specific term will be equal to that, it has to give you a whole number. Unless I said like which term will be less than this or more than this, it might not be a whole number. But if they ask for a specific term, it most likely will be a whole number. All right, so if we have the square root of 3844, then we get 62, okay? So therefore I can apply a difference of squares. I can say, okay, n plus 62 and n minus 62 equals to 0. All right, so then we have that n is equal to negative 62, or that n is equal to 62. Now also something which is should be common knowledge, the negative value is not applicable, because it's like, for example, this is your first term, this is your second term, there's no negative term. So n is always positive, so that means that this value is your answer. All right, and that's, yeah, so what I can do is actually also the other way of solving this would have been to say, okay, n squared is equal to 3844, then we take the square root on both sides, basically. So this would be n is equal to the square root of plus or minus 3844, and then you'd have n is equal to plus or minus square root of that was 62, and then since we don't have a negative value for the number of terms, we have therefore that n is equal to 62. Now this looks easier, it probably is. This is probably better, but yeah, it's your choice. Okay, so question 11.1. The number sequence has a general term Tn equals to 2n squared minus n plus 2. Which term of the sequence is equal to 2852? Okay, so basically, once again, we see, okay, this is the term value, meaning we need to substitute it for Tn. I'm going to start by just saying 2n squared on this side minus n plus 2 should be equal to 2852. All right, and then we bring it over to this side. Now we have to actually solve for a quadratic equation. So 2n squared minus n, and if we bring this over, we get plus 2 negative 2852 equals to 0. So 2n squared minus n minus 2850. Okay, now in this case you don't have a choice. You have to bring everybody to the one side and solve, factorize and solve, okay, because this is a quadratic equation. You've done loads in grade 11. So in this case, I'm not going to try and find factors. It's just definitely too big to try and find all the factors, see if there is there's factors, and you probably will find factors, but I'm just going to go ahead and substitute it into the quadratic formula. So minus b plus minus b squared minus 4ac over 2a. Okay, so b's value is negative 1. plus or minus, so negative 1 squared plus, minus 4, 2, and C's value is negative 2850 over 2 times by 2. Okay, right, so now substituting it in, also another thing that I do when I substitute this in, I actually would like to, I normally just first simplify it a bit, like minus and minus is 1. It's less trouble than having to type in all of those brackets into the calculator. If you're not very confident in maths, I'd say just type it in. So minus 1 squared is a positive 1. A minus and a minus is a plus. And then you'll have 4 times 2 times. We can actually do that quickly. It's 4 times 2 times 2850. And that gives me 22800 over 4. That's just easier for me to type in, I think. But once again, up to you. We have 1 plus square root of, so I'm just going to go ahead and say 22801 over 4. And that gives us 38. So n is equal to 38. Or n is equal to, then if we substitute in the negative, we get negative 75 over 2. All right, so this one is obviously not applicable, and because for 2 reasons. We don't have a negative number doesn't exist when it comes to patterns, and then also it has to be an exact value because they say equal to, so it has to be an exact value. So that's going to be n is equal to 38. Right, then for question 11.2, the number sequence has a general term Tn equals to negative 4n squared plus 13n plus 2. Which term of the sequence is equal to negative 933? Okay, so once again, this is my value for my term, so we're going to substitute in Tn. Negative 4n squared plus 13n plus 2 is equal to negative 933. And then since this is a quadratic equation, we're just going to put it in standard form. So I have negative 4n squared plus 13n plus 2 plus 933 equals to 0. So negative 4n squared plus 13n plus 935 equals to 0. Okay, and then just substituting it into the quadratic formula, we have minus b plus or minus b squared minus 4ac over 2a. And then we have negative, so b is 13, negative 13 plus or minus 13 squared, square root of 13 squared, minus 4, a is negative 4, and c is 935 over 2a. All right, I'm just going to simplify it before I type it into the calculator. 13 squared, not 3 squared, 13 squared is equal to 169. And a minus and a minus is a plus, and then 4 times 4 times 935 is equal to 14,960 over negative 8. Okay, now let's do the typing in. Negative 13, start with plus, square root of 169 plus 14960 over negative 8. So that's negative 55 over 4 plus, or so that's n, or n is equal to, so let's type in the negative 17. Right, so this is then our answer, n is equal to 17, and this one is not applicable. Question 11.3, we have this number sequence has a general term of Tn equals to this, which term of the sequence is equal to 431. Okay, so 7 over 2n squared minus 25 over 2n plus 2 must be equal to 431. And then putting it into standard form, we have 7 over 2n squared minus 25 over 2n. If I bring this over, it becomes a negative. So then it's going to be, and if I say negative 431 plus 2, I get negative 429 equals 0. And then another thing that I'm going to do to simplify this quadratic equation is to get rid of my fractions. And in doing that, I'm just going to multiply each term with my lowest common denominator, which is 2. So that leaves me with 7n squared minus 25n, and then that times by 2, I think it's 858 maybe. So that's 429 times by 2. Okay, so 858 equals to 0. Okay, so substituting all of this into the quadratic formula. Minus b plus or minus b squared minus 4ac over 2a. So negative 25 for b, plus or minus, then b squared is negative 25 squared, minus 4 times by a is 7 and c is negative 858 over 2a, and a is 7. Okay, so simplifying, we've got positive 25 there, plus or minus, and then 25 squared is 625. Now minus and minus is a plus, and then 4 times 7 times 858 is equal to 24,000 and 24 over 14. Okay, so n is then equal to n is equal to 13, or n is equal to negative 66 over 7. Okay, this guy is not applicable, and then this is our answer. Okay, that's done. Now the final section. So example 12 says the following quadratic sequence is given. Determine the values of x and y. Now what's important to note is that they must tell you what sequence it is, and in this case we know it's a quadratic sequence. And what we're going to do is, what we know about quadratic sequences is their second difference is constant. And here we see that two of these terms are variables that we need to solve, and what we can do is to find the first differences and then the second differences in terms of x and y, and then see if there's anything we can use like the second differences that are equal to solve, or to set up an equation to solve. Okay, so if I just rewrite this, let's say we rewrite it over here, we have x, 1, negative 6, y, and negative 14. Okay, and then what happens is we've got the first difference. So for here we've got 1 minus x Okay, and then this one is -6 minus 1 is -7. And then this one is y minus -6, which becomes y plus 6. And this one, I'm just going to write it way over here, is -14 minus y. So that's -14 minus y. And then to find the second differences in terms of x and y, so we have -7 minus, in brackets, 1 minus x, very important because it's two terms. And on this one, we have y plus 6 minus -7. And for the last one, we have minus 14 minus y plus 6. Okay, now this is then our second difference in terms of x and y. And let's just simplify this. This one becomes -7 minus 1 plus x. And we can simplify it further. We can say that's x minus 8. Okay, and this one is then 6 plus 7 is 13, so that's y plus 13. And on this side we have multiplying out the brackets, minus y minus 6, so minus 2y minus 20. All right, so there we have it. Now what do we know is that these are equal to each other, but I can't equate these two because that's not going to make any sense. I'm going to have two variables to solve for, which is not possible in that equation alone. Although if I look at this second one and this third one, they only contain y. So for my first solution, I can actually equate these two together, and I can say, I'm just going to do this for space. All right, so then I can say y plus 13 is equal to -2y minus 20, and then solve for y. So all the y's goes to the one side, plus 3y is equal to -20, oh that's plus 2y, -20 minus 13, and then that becomes 3y is equal to -33, I believe. Okay, so y is equal to -11. Okay, and then to find x, we can actually now equate these two. Since we know the value of y, we can now say, okay, x minus 8 is equal to, this value is -11 plus 13, and solve for x. So x is equal to, this becomes 2 plus 8, so x is equal to 10. All right, there we have it. Y's value and x's value. So question 12.1, we're given this sequence, and it's a quadratic sequence. Calculate the value of x. All right, so this is quite an easy one. I'm just going to write this out with space between them, x and 37. So first difference, from there to there is 5. Then we have from here to here x minus 9, and then from here to here we have 37 minus x. Okay, and then the second difference is x minus 9 minus 5, because remember you always take the next one minus the previous one. So x minus 9 minus 5, and then this one and this one is 37 minus x minus 9. Okay, so let's maybe simplify this just, x minus 14, and then on this side 37 minus x plus 9, so this is 37 plus 9 is 46 minus 2x. Now we know that these both are the second differences, so we can just basically equate them to each other and solve for x. Minus 14 is equal to 46 minus 2x. Bring all your x's over to the one side, so x plus 2x is equal to 46 plus 14. So 3x is equal to 5660, yes. And then divide both sides by 3, so x is equal to 20. Then for question 12.2, the first 5 terms of a number sequence with a constant second difference are as follows. Calculate the values of x and y. Okay, so let's write them out first. 34, y, 16, x, and 6. Okay, and then let's find the first differences. So from there to there, we've got y minus 34. Then from there to there, we have 16 minus y. From there to there, we have x minus 16. And from there to there, we have 6 minus x. All right, now second differences. Y, or 16 minus y minus 34. Remember your brackets. And then over here, we have, gonna need some space. We have x minus 16 minus 16 minus y. And then there we have 6 minus x minus 16. Okay, let's simplify these once again. This becomes 16 minus y plus 34. So this is going to be, that together gives me 40 plus 10 is 50. So 50 minus 2y. This guy simplifies to, let me just work down here. This simplifies to x minus 16 plus y. Right, so this becomes x plus y minus 32. Okay, and then this guy is 6 minus x plus 16. So 6 plus 16 is 22. 22 minus 2x. Okay, so basically now we know that this is all the second differences, and we know that they have to be equal. So let's see if we have 2 that only contains x or y, and we actually don't. This complicates matters a bit. So what are we going to do? If we can equal this, okay. So what we're going to actually do is we're going to equate these two to each other, and then we're going to have an equation, and then we're going to equate these two to each other. We're going to simplify and have an equation. So this is going to be like simultaneous equations. All right, so let's start by doing that. So let's say 50 minus 2y is equal to x plus y minus 32. Okay, to simplify this, I'm just going to bring my variables to the one side, my constants to the other side. So minus 2y minus y minus x is equal to negative 32 minus 50. And we have minus 3y minus x equals to negative 82. Okay, let's just make this positive. 3y plus x equals to 82. Just divided all the terms with a negative. Okay, and then for the other one, we'll have this equal to that. So x plus y minus 32 is equal to 22 minus 2x. Bring the variables to the one side, so x plus y plus 2x equals to 22 plus 32. And then we have 3x plus y equals to 22 plus 32 is 54. Okay, so that's our first equation, and that is our second equation. Now, that's now up to you. Do you want to do substitution or elimination? I always prefer substitution. I'm basically just going to isolate x over here. So x is equal to 82 minus 3y, and then substitute this x value into my second equation. So this is then going to be 3, and then for x's value 82 minus 3y. Actually, scratch that, I'm going to do it over here. So 3, and then 82 minus 3y plus y equals to 54. Okay, so here we're going to solve for y now. So multiplying in the 3, we get 82 times by 3. So that gives us 246 minus 9y plus y equals to 54. So this is then negative 8y equals to 54 minus 246. So minus 8y is equal to 54 minus 246. And that's equal to negative 192. And then if we divide both sides by negative 8, or just divide by 8 to get the value, negative 24. Okay, so this is y equals to positive 24. All right, now for x. So let's use this equation over here and substitute in y's value. Then we get x's value. So x is equal to 82 minus 3. In this place of y we have 24. And then that would give us 82 minus 3 times by 24. So that's equal to 10. X's value is equal to 10. Right, that is done.